To implement this algorithm, we need to perform a breadth-first traversal in our graph. So we're going to use a queue to implement this, just like how we implemented the breadth-first search algorithm. However, the order of nodes we visit is a bit different in this algorithm. In the breadth-first search, the order didn't matter. But now, as we're done visiting a node, we want to go to its neighbor that is the closest to the start node, okay? So here we need to use a priority queue instead of a regular queue. We talked about priority queues in the first part of this course. In a priority queue, items move to the front of the queue based on the priority. So as we're examining each neighbor, if we find a shorter path to a neighbor, we update our distances table and push a new item into our priority queue. So the priority of this item is going to be equal to the new distance we have calculated. So if a neighbor is closer to the starting node, it will be moved to the beginning of the queue, okay? Now, for this exercise, I want you to use the priority queue class in Java. Let me show you how it works. First, I'm going to declare this method, public integer get shortest distance. We give it two parameters, from and to. Now here we want to create a priority queue object. The class that we are going to use is the one that is declared in the java.util package. As you can see from these angle brackets, this is a generic class. So here we need to specify the type of objects that we want to store in this queue. So here we want to store node objects. Let's create this queue, new priority queue. Now look at the constructor of this queue. This constructor is overloaded, which means we have a few different ways to call it. One way is to pass the initial capacity. Another way is to pass a comparator object. What is this comparator? Well, this is an advanced topic, and I'm going to cover it in my upcoming advanced Java course. But for now, let me give you a quick fix. This queue uses a comparator to compare two objects. The job of this comparator is to determine which object should be moved to the beginning of the queue. So here we need to create a comparator object and pass it to our priority queue. But how are we going to do that? Well, here we have this comparator interface. So let me put this on a new line. Comparator. Look, this interface is declared in the java.util package, and it has a method called comparing int. This is a factory method that creates a comparator object for comparing two integers. Now, what is that integer here? That is the priority of a neighboring node. Let me show you how to use this method. So we call this method, and here we need to pass a function. Now I'm going to show you a shorthand to create a function. If it looks strange to you, don't worry about it. Just bear with me. I will cover this in detail in my upcoming advanced Java course. So this function is going to take a node object because every object in this queue is a node. So I type n here. This is like the parameter of that function. Then we add this arrow, and after this arrow, we write the body of that function. We want that function to get a node and return the priority of that node. So we can type n dot, but here we don't have a priority field. We only have edges and label. One way is to add the priority field here, but this is a bad approach because we need this field only for this algorithm, nowhere else. So we don't want to pollute this class with fields for different algorithms. That is a bad practice. A better approach is to wrap this class inside another class and call it node entry. Let me show you. So temporarily, I'm going to comment out this code. And let's just return 0 to fix this compilation error. In this class, we're going to declare a private class, node entry. This class is going to have two fields. One is a node. The other is the priority of that node. So integer priority. And just like before, let's create a constructor to initialize these two fields. Okay? Now, back to our priority queue. Let me bring this code back in. Now that we have this new class, we want to create a priority queue of node entry. So every entry in this queue is a node entry object, right? Now, when we call comparator.comparingInt, instead of a node, we're going to have a node entry. So I use NE as an abbreviation of node entry. We could call this anything. We could call it X. It doesn't matter. It's like the parameter of a method, okay? So node entry goes to node entry dot priority. So this small anonymous function that we're creating here takes a node entry object and returns the priority of that object. Now, this comparing int method will create a comparator object based on this function. So as we add node entry objects to our queue, this comparator object is going to look at the priority of these node objects and determine what node object should be moved to the front. Okay? So when we create a new priority queue object in the constructor, we should pass this line. So this is all about this priority queue. Now, in this algorithm, we need to create this table. How are we going to do that? That's super easy. Basically, we need two hash tables. In both these hash tables, our keys are node objects. Our values are different. In the first hash table, our values are integers. We can call this hash table distances. In the second hash table, our values are node objects. So we map a node to another node, to its previous node, okay? So go ahead and spend 20 to 30 minutes on this exercise and then come back here.